Hello, welcome to the video lecture on canonical and standard form. Minterm. A binary variable may appear either in its normal form or in its complement form. Now let us consider two binary variables x and y which are combined using AND operation. Since each variable may appear in either form, there are four possible combinations: x bar, y, x y, x, y bar, x, y. Each of these four AND term is called minterm or standard product term. Each minterm is obtained from an AND term of n variables, with each variable being primed if the corresponding bit of the binary number is 0 and unprimed if it is 1. A symbol for each minterm is shown here in table, which is of the form mj, where j denotes the decimal equivalent of this binary number. So let us consider two variables x and y. Since there are two variables, there will be four different combinations: 0, 0, 0, 1, 1, 0, 1, 1. The minterm corresponding to this combination. Since x takes a value 0 here, the variable is primed. Y also takes a value 0 here, the variable y is also primed. So the minterm corresponding to this is x bar, y bar. Minterm corresponding to this is x bar, y. And minterm corresponding to 1, 0 is x, y bar. And the minterm corresponding to 1, 1 is x, y. So the designation, the short form of representing the minterm, so we represent it as mj. The j, suffix j, represents the decimal equivalent of this binary number. Same way, now let us consider three variables x, y, z. Since there are three variables, there will be 2 part 3 combinations, 8 combinations. So there will be 8 minterms. The corresponding minterms for all the combinations are shown here and the designations are written here in this table. So since x, y, z, all the three are 0 here, the minterm corresponding to this is x bar, y bar, z bar. Maxterm. In a similar fashion, n variables forming an OR term with each variable being primed or unprimed provides 2 power n possible combination called maxterm or standard sum terms. Each maxterm is obtained from an OR term of n variables, with each variable being unprimed if the corresponding bit is 0 and primed if it is 1. So let us consider two variables x and y here. So there will be 4 different combinations. The corresponding maxterm for this is shown here in figure. So the corresponding maxterm is, since x takes the value 0, so x is unprimed here. Y also takes a value 0, it is unprimed here. So the minterm corresponding to 0, 0 is x or y. The same way for 0, 1. Since x is 0, it is unprimed. Since y is 1, it is primed. So it is x plus y bar. Here it is x bar plus y. Here it will be x bar plus y bar. The shorthand designation for the maxterm is shown here in figure. Since it is maxterm, it is represented by capital mj, and the j is the decimal equivalent of the binary number. This is denoted as capital M0, M1, M2, M3. The same way, now x, y, z takes 3 variables. There are 3 variables. So since there are 3 variables, there will be 2 part 3, 8 different combinations. So the 8 different maxterms are shown here in the table, and the designation is also shown here. Since x, y, z, all the 3 takes value of 0, so all your x, y, z are unprimed here. So it is x plus y plus z. Here it is 0, 0, 1. So it is x plus y plus z bar. The corresponding designation is capital M1. Now let us consider a simple example to convert the truth table to a Boolean function. A Boolean function can be expressed algebraically from a given truth table by forming a minterm for each combination of the variable that produces a 1 in the function, and then taking the OR term of all those terms. Let us consider two functions f1, f2 here. So now we are going to write Boolean expression for these two functions f1 and f2 from the truth table. So the Boolean function can be written by taking minterms which corresponds to the value 1. So I have 1 here, so the corresponding minterm is x bar, y bar, z. We have 1 here, so the corresponding minterm is x, y bar, z bar, plus the corresponding minterm to this is x, y, z. So the function f1 can be the sum of the 3 minterms m1, m4, m7. The same way, the function f2 can also be represented in Boolean function as. So wherever we have 1, so we write the corresponding minterms and then we OR those functions. So here it is m3 plus m5 plus m6 plus m7. Now let us try to complement this Boolean function. So to find the complement of the Boolean function, so we have to write what is f1 bar. So it may be read from the truth table by forming a minterm for each combination that produces a 0 in the function and then ORing those terms. So wherever we have 0, for those functions we write what is the equivalent minterm and then ORing those minterms will result in the complement of the Boolean function. So f1 bar can be represented as, so I have a 0 here, so I write the minterm equivalent to this number. So it is x bar, y bar, z bar. I have a 0 here. I write minterm equivalent to this one. So wherever I have zeros, I write the minterm of those numbers and then I make OR of those product terms. I sum up all those product terms. That will be the complement of the Boolean function. Now if we take complement for f1 bar, that will result in f1. So by using De Morgan's theorem, to find the complement, so to complement of x1 bar, y1 bar, z1 bar, it will be equal to x double bar plus y double bar plus z double bar, which will be equal to x plus y plus z. The same way, x bar, y, z bar, the whole bar, which is equal to x plus y bar plus z. So this is nothing but m0. This is nothing but capital M2, M3, M5, M6. So this is nothing but the product of the Maxterms. So they can be expressed as a product of the Maxterm. Logic function. Logical functions are generally expressed in terms of logical variables. Values taken on by the logical function and logical variables are in the binary form. An arbitrary logic function can be expressed in following forms. Product form. The function is generally referred to as a product. The logical product of several variables on which a function depends is considered to be a product term. The variables in the product term can appear either in complement form or uncomplement form. For example, so A, B, C bar represents the product term. So variables A, B, C are multiplied using function, logical multiplication. Sum term. An OR function is generally used to refer a sum. The logical sum of several variables on which a function depends is considered to be a sum term. Variables in a sum term can appear either in its normal form or in complemented form. For example, sum term. This is sum term A or B bar or C. Logical addition happens here. Sum of products. The logical sum of two or more logical product terms is called as sum of product expression. It is basically an OR operation of unoperated variables. So this is an example. So we take product terms and then we are going to sum all the product terms. That is sum of products. So AB or AC bar or B bar C. Product of sums. A product of sum expression is a logical product of two or more logical sum terms. It is basically an AND operation of OR operated variables. So here we are going to take the sum terms and then we are going to product all the sum terms. That is called product of sums. Now let us consider sum of minterms. So now we are going to express the Boolean function in a sum of minterms. So now let us consider this function A plus B bar C. So there are three variables available in this minterm A, B and C. When we take the first term, there are two variables missing. B and C are missing here. So what we are going to do is, we are going to add this with A is now multiplied with B plus B bar. So since B variable is missing, we are going to initially multiply A with B plus B bar because B plus B bar is 1. So A dot 1 is same as A. So now multiplying A inside, we get AB plus AB bar. So now C term is missing in this variable. So now what we do is, so we multiply AB with C plus C bar because C plus C bar is 1. The same way AB bar is now multiplied with C plus C bar. So this is also equal to 1. So now multiplying AB inside, we get ABC plus ABC bar plus AB bar C plus AB bar C bar. Now we take the second term. As you can see from the second term, variable A is missing here. So we are going to multiply this with A plus A bar. Since A plus A bar is 1, B bar C into 1 is same as B bar C. So multiplying B bar C inside, we get A B bar C plus A bar B bar C. Now function f is the sum of these two terms. So now it is equal to ABC plus ABC bar plus AB bar C plus AB bar C bar and plus AB bar C plus AB bar C. So now these two terms are same. We know x plus x is equal to x. So combining these two terms into one term, we get A bar B bar C plus A B bar C bar plus a b bar c plus a b c bar plus a b c. This is nothing but this corresponds to minterm M1, this corresponds to minterm M4, this corresponds to minterm M5, this corresponds to minterm N6, and this corresponds to minterm M7. So this is now expressed in sum of minterms, sum of 1, 4, 5, 6, 7. So it is convenient to express the Boolean function in sum of minterms in the short notation in this form. The summation symbol stands for ORing of the terms. The number following it are the minterms of the function. An alternate procedure for deriving the minterms of the Boolean function is to obtain the truth table of the function directly from the algebraic expression and then read the minterms from the truth table. Now let us consider this function a plus b bar c. Now let us draw the truth table for this function. So since there are 3 different variables, there will be 8 different combinations. A, B, C can take 8 different combinations. So for all those substituting all those combinations in this function, we will find what is the function f. So directly from the truth table, we can express the function in sum of the minterms. Wherever we have 1, the corresponding minterms are written here. I have 1 here. The equivalent of this is 1. I have 1 here. So this is 4, 5, 6, 7. So that is how the minterm can be expressed. The function can be expressed as the sum of minterms. Next, product of maxterms. Each of the to express the Boolean function as a product of maxterms, it must be first brought into a form of OR terms. This can be done by using distributive law. Now let us try to express this function as a product of maxterms. First we will convert the function into OR term using distributive law. Since there are 3 different variables x, y, z, so the first term contains only 2 variables x, y. So now we have to include the variable z here. The same way we have to include the variable y here. So in order to first convert this into product of maxterm, we have to express this using distributive law. So expressing this function using distributive law, we will have xy plus x bar multiplied with xy plus z. The same way this has to be expressed using distributive law. Xy plus x bar can be represented as x plus x bar multiplied with y plus x bar. The same way this can be expressed using distributive law. X plus z multiplied with y plus z. So since x plus x bar equal to 1, we have x bar plus y multiplied with x plus z multiplied with y plus z. So when we consider the first term, this first term, so now they are expressed in the product of some terms. So in the first term, variable z is missing here. So what we are going to do is, we are going to add z bar to this one. Since z into z bar equal to 0, x bar y plus 0 will be same as x bar plus y. So again, expressing this using distributive law, we get x bar plus y plus z multiplied with x bar plus y plus z bar. The same way the next term, x plus z can be expressed as, since y is missing here, we are going to put y bar here. So again, expressing it in distributive form, we get this. So the function f will now be expressed as a product of maxterm. This corresponds to m0, m2, m4, m5. So this can be represented phi of 0 to 4, 5. So this can be expressed in maxterm. This represents the product term, the unfunction. Conversion between canonical forms. So now let us convert this function f, which is expressed in sum of minterms, to product of maxterms. So now let us consider the variables a, b, c. So they are expressed in sum of minterms 1, 4, 5, 6, 7. The complement of this can be expressed as f bar can be denoted as summation of whatever terms are missing here. We are going to represent that here. So 0, 2, 3 are missing here. So which is equal to 0, 2, 3. So this is equal to m0 plus m2 plus m3. Now again taking complement for this function using De Morgan's theorem. So we will get m0 plus m2 plus m3 the whole bar, which is nothing but m0 bar dot m2 bar dot m3 bar. Already we know. So mj bar is equal to capital Mj. So complement of the minterm is equal to maxterm. So which is equal to capital M0 into M2 into M3, which is equal to phi of 0, 2, 3. So this can be converted from one form to the other. Thank you for watching this video.